Hey everyone, welcome in to another daily editorial here on the KE Report. I'm getting another update from Graphene Manufacturing Group, and we're going to be focusing on recent news testing data on the Thermal XR durability and heat transfer focus. That was released October 23rd, as well as a general update on the Australian federal government engagement that the company has ongoing. And I'm also going to take care of some of the questions on the Lubricant Division that you all have sent me. Thank you again for sending me all your questions. And hey, look, I appreciate all those questions coming in, so I keep bringing back on Craig Nicol, founder and CEO of Graphene Manufacturing Group. The company is traded on the TSX Venture Exchange under the symbol GMG and on the OTCQX under the symbol GMGMF. Craig, let's take care of the recent news. The most important recent news is this testing data on the Thermal XR. I've received a lot of questions on when we would hear some of this testing data. You addressed them and said it's coming. Now we have that news release, the main data points being durability and heat transfer. Craig, just summarize it for us. What's the main takeaway?
Yeah, great to be back on, Corey. Look, this is a huge milestone for the company. 8 years in the making to get to this point, to understand the coding and to be able to test it for this long in third-party laboratories is a really big milestone. The key takeaways is we can now say with confidence that our coating can survive 15,000 hours of continual salt sea spray being dripped on it, which is one of the longest lasting coatings in the world. It's still going. It's not got any corrosion yet, so likely that'll go on for some time. So it's definitely in the top 5 longest lasting coatings, and it's probably going to keep going for some time, as in it doesn't seem to have any shine of any wear and tear so far. But the other point, which is probably more significant, which to our knowledge is the only company kind of product that's out there like this, which clearly outlines that our coating can increase the thermal radiation of aluminium by around 8 times. And then if you account for the air cooling, the natural air cooling, then we're actually about 2.2 times more heat transfer when you have our coating as against just having a bare aluminium. And that is an astounding number. Now this is at 100 degrees Celsius. It's a bit less, obviously, the lower the temperature, but it is an astounding number, and it shows that we can now understand what this coating can offer. And if you can do 2.2 times more heat through the same aluminium pipe in a condenser coil, in an air conditioner, or in a data center, or in a range of things like heat sinks in phones or laptops or hard drives, once you understand that, and you understand the lifelong, the copper, the test on corrosion resistance with the coating as well, you pretty much put two together and you say our coating should be on everything that is above 50 degrees Celsius, 100 degrees Fahrenheit, and is basically trying to shift heat, which is an enormous amount of materials and equipment and pumps and engines all over the world. And it's basically a representation of the types of companies that are in discussions and are testing our products right now. In that there's so many different ways that our coating can help companies make their products more efficient, save costs, save power costs for themselves, and also reduce emissions. So it's a big achievement. It quite clearly shows that we understand the product, how it works, and it's really quite an achievement in itself. And it really helps us explain to customers, well, this is what you put this on and this is the effect, and, let's just do it. So I wish it was that simple. Eventually it will be, once it's understood that what we can do with this coating. But right now, there's still a lot of testing that people want to do to really understand what it does. It's so transformational that it actually makes people really think, is it true? And so they need to still test it. Now, one day, that won't be the case, and it'll be like ordering a Big Mac, but not yet. So that's what we're working on right now. But with this data out there, it really helps us to explain this to customers. So this is as much to help shareholders understand it, but what this also enables us to do is we send this to our large companies are engaging to say, hey, look, this is what we're up to. This is really clear. Hopefully this makes sense, and let's get this project going where we can, coat your equipment and your products and make it more efficient. So, it's a big achievement. It's got, hopefully, in our mind, really going to spur on a lot of sales to large equipment manufacturers and industrial processing companies like LNG companies and such things. We're in the process of talking to a number of them and trialing and testing the product, but that they still need to go through the process. But this shows you the data is there, it makes sense, it's been signed off by a world-leading university, and by all means, anything that wants to repel heat should be actually covered in that coating.
So when we're talking about the durability there, that 15,000 hours of corrosion protection, can you put that into real world terms? What's the approximate time frame that gives for a product that Thermal XR is sprayed onto?
Yeah, I mean, obviously people know, there's about 8,000 hours or so in 1 year. So it's not really saying you can last 2 years, because this is continual salt water being dripped on it at very high concentration. It's a standard test. So I think it's more to say that the expected salt water that could come onto corroded pipe or corroded metal, our coating will substantially increase the life of your asset to the point where it's highly likely that something else will break instead of the corrosion of this pipe that we're covering. That's the type of kind of conversation you can have with people. We warranty the coating for 5 years. So that gives you an idea of how long we think the coating will go. We think, we'll probably be able to extend that coating life, that warranty life in some time. But yeah, so you can't really go, oh, that means my equipment can run for 15,000 hours. It probably means, it does can, but what probably means it can probably last for 30,000 hours or 50,000 hours, because you don't have continual salt sea spray or dipping of salt sea spray for air conditioners, or most air conditioners anyway. Normally it's an occasional gust of salty water. So it is a big achievement to have such a long lasting, coating. We think that there's two things it's doing. One is the graphene is providing an air gap inside the epoxy acrylic coating we have, and that graphene air gap means that there's no way for the air to get in to create the corrosion. But also the graphene that we use, as you guys know, is similar to the graphene we use in our battery. So therefore it's creating like a capacitor type resistance to corrosion, and therefore we think that it should have an even longer life than normal barrier coatings, because it's actually counteracting the corrosion which comes from the cathodic reaction from metal to air and water surface. So we think we got a good background or basis for this thing to go even much further, to the extent that, I think you'll find that the equipment will fall away otherwise before this coating will corrode.
So when it comes to the heat transfer data, yes, 2.2 times more efficient at heat transfer than bare aluminum, 8.6 times more efficient heat transfer with radiative heat. What are maybe the biggest markets that this impacts?
Yeah, I think just straight out radiation heat transfer is your heat sinks. So for your phones, your laptops, your hard drives, there's heat sinks generally in there, and we can fundamentally change those with this coating. Yeah, we can make that 8 times more heat transfer, and then we can wick that heat away. The product can last longer, perform better because the temperature is lower. So that's one. Yeah, I think clearly when you're talking about with the fan, obviously you're powering the fan, and that heat transfer will happen in a way which is, you got the forced convection happening with also the radiation from the coating, and so there's less of an impact from the addition of the coating, but it's still a 27% increase in these calculations in this rig that we built and tested. 27% increase is massive in an air conditioner, even with the fan going. And that's the number we normally see on an air conditioner system when we apply it in getting the full whack out of the coating, especially in in an existing coating we're applying on site, we can see a number of power and energy efficiency gain around that. So that all lines up with what we see. The temperature is 100 degrees Celsius. You don't typically see that in air conditioners. Typically they're kind of 60 degrees or so Celsius. So that's why it can sometimes be down to 10 to 15%. But really high heat transfer applications, 27% makes sense. But with the fan on. And that fan cooling is obviously taking power, whereas we don't need power. Our coating emits heat without any power provided to it. It just pushes the heat out just being on the actual metal. So that fan cooling takes power, and that's it's obviously something you don't really want to necessarily use that. So typically you can basically stop the cooling about 20%, 25% shorter time period. And that's typically what you see with an air conditioner. You'll see when we put the air conditioning coating on, when we put our coating on the condenser coil, the time for it to cool something is 20 or 30% faster. And then the compressor turns off within that. That's typically what you see. So that all goes round, that all makes sense. What we see in the actual units, in the brand new units. Now, data centers are obviously becoming more of an issue around energy demand, especially with AI data centers. So these are obviously opportunities, that we can work on for them, and we have some in progress for that. And then there's obviously other things like processing of metals, other industries like processing of metals, and also LNG, which is a great big fridge, basically liquefied natural gas. They chill it down to negative 160 degrees Celsius. So those are also needing a lot of heat transfer, and you're typically using fans there as well, and especially in LNG plants. And so, even 20% for them is just a number that honestly they need to do a lot of work to actually believe that, because it's such a huge number. But what that means is you can actually start to reduce that the actual amount of energy you put into the fan, and that radiative heating can actually take some of that over. So there's a range of applications, but heat sinks is where you're not even using a fan. That's where we're 8 times more heat transfer, which is a startling number. But then when it goes all the way through the fans, even 27% is huge as well.
So Craig, I always ask you about that US EPA approval process. Does any of this data help move that process forward? You've already said that with this new application you're putting in, it's estimated to be about a 12-month process, but does this data speed that up?
Yeah, look, there's a very big chance that it will, because we've got a potential for it to jump into what's called a positive environmental product approval kind of slip lane, which is about a 3-month process right here. Now, that could be the case, and if that's the case, we go from 12 months to 3 months, and hence, we'd be up and running with our approval early next year. With data like this, it certainly makes you think that we could get into that swim lane. We can only hope, and then see how it goes.
Well then, Craig, I guess the big question being, with this data, does this speed up any of your sales? How does this help get this product, Thermal XR, out to market?
Yeah, so we're talking to a lot of companies in a lot of different industries, and we're testing, over 10 big global companies in different industries in this range, in this area. What you do with this kind of announcement is you put the cat amongst pigeons, because they're all looking around on how to make their product better. And if they suddenly see that we've announced this to the world, and they know we're talking as a result potentially to their competitor, it can hopefully spur up reactions. Because the company that gets there and launches the product first will likely capture that market share and more efficient products and a more advanced product than potentially their competitors. So hopefully this provides a bit of more impetus to kind of push it along. The engineers, especially process engineers who we're largely selling to here, are very data driven. They're very analytical. They have to be. Their job is to make something amazing, like an air conditioner, which shifts heat magically from one space to another, which about 0.1% of the world actually understands how it works. and for all a very low cost amount of money. And everybody wants it to run for a low amount of money per day, and they all want it to run for as many years as they can. So they're on a losing argument on many different fronts, and they really need to make sure this works on their side as much as possible. This data goes a long way, but they will always need to make sure that it works on their equipment, and that's obviously what we've got to go through. I think at some point it will be like ordering a Big Mac, and you'll go, I just want graphene coating on my air conditioner, and then you'll then have more than 15,000 hours of corrosion resistance, and you'll then have a far more efficient air conditioner. But until then, we've got to actually educate people of what we're like. And then, as hopefully one day, I think one day you'll see just us as an option this is how it's done. And everybody understands that graphene air conditioning coated products are much more efficient.
Yeah, isn't that the dream? Hey, that every company just says, we have to put this on our product. That takes some time. So, hey, look, I'll keep asking you about it because I keep getting those questions.
Yeah, please keep asking. Yep.
What other testing is ongoing then of the thermal XR that we should be aware of?
Yeah, there's a range of tests. There's probably close to 20 different tests that we're doing in different ways, internally, externally, universities, ASTMs, external laboratories, always looking at ways of understanding it and breaking it apart and putting it back together in different ways of acid testing for different applications there. What is the highest temperature we can push? We think we can do it much higher than we originally thought. And then freeze. So there are some really great applications we think we can offer as a hardcore snowed-in condenser coil outside on a heat pump, which might be ice bricked up, and you turn on the defrost cycle. We've already recorded that we're at 25% less energy to repel ice off our coating than normal aluminium. So there's another application, but we've got to do the testing in pretty cold weather environments. Then there's all different types of applications of the coating. So we spray, and we have a number of spray guns that we use, and we offer, help people procure them, to use. And then we've implemented a new technology called what's called flow coating, a technology which pumps the coating into the coil, and that is another way to get it into really tight-facing coils. And then there's dipping. So there's a number of ways of coating it. We can vary the coating as well, which we can do for different customers. We also then have really big, intense hardness testing. We've already got the highest adhesion coating level there is of any coating there is. People want to do it more. So we're getting this really, multi-ton type scratch-proof resistance, which we're working on. We've already done quite good work there. And then we've got some customers who want it to be a cosmetic coating. So they want it to look beautiful as well and nice to touch. So we're doing work there as well, because there's some of the personal electronics, they want it to be amazing to touch, move the heat faster, having corrosion resistance, lightweight, looking good. And so we've got to do all of those as well. Well, all of those things are good to do because we know we'll have others who are like that, but they do. It is hard work though. It's not simple, but it come a lot from the fact that we make it all the way through from the graphene. It really helps because we can modify what we need there all the way through.
All right, Craig, thanks for addressing those questions. Let's move on to the October 21st news release. It was a business update on the Australian federal government engagement. Just summarize it for us. What do you hope to get out of this engagement with the Australian federal government?
Yeah, look, there's multiple conversations we're having, and it's always just good to have these conversations. That's really what it's about, to make sure they know we're here and we know they're there and what their policies are, and that we fit within the policies as much as we can get them to the extent that they are willing to, adopt them into for us. There's a number of funding opportunities that are available for non-dilutive funding, which for expansion we'd always love to do, and our shareholders I know would also love to do as well. Then really just around, because I'm also the chairman of the peak battery manufacturing body of the country, so talking to them about the industry and making sure that the government is aware of what the industry is up to in terms of going to the next stages of battery manufacturing and critical mineral manufacturing in the country. We obviously make a critical mineral as well called graphene from natural gas, and that's quite a unique thing that we do. being a critical mineral producer, a cell producer, cathode producer, and a cell producer, battery cell producer, there's basically there's probably nobody else, maybe one or two others in total, including privates in the world, that do that. So we want to make sure that they are aware that we are of such a beast, and we do exist, and it's happening here, and we've got worldwide companies that are working with us. Obviously, Rio Tinto is one of our public partners, and Rio Tinto has obviously got a big profile in Canada, and obviously huge profile in Australia. One of the largest miners in the world, one of the largest aluminium companies in the world. And let them know that that Rio Tinto is also doing work in this space as well, which is obviously important, because that means that the industry wants to be more green. That means the mining industry and business in general want to use these types of products, so they understand that this is something that's happening in the industry, and the policy can be directed towards it. So we're across critical minerals. So we met the mining minister, as well as we met a number of different types of ministers who are involved in the battery industry and energy efficiency as well. So it wasn't necessarily one or two or three meetings; it was multiple. And it's good just to be aware of what they're up to, what they're doing, and hopefully we should be able to move into some kind of non-dilutive funding wherever we can, where we meet the government's requirements and they want to help us as well.
Well, Craig, you are right. Everyone's being pressured to be more green. So if this does help with savings of any sort and transitioning to that green economy, well, hopefully that just provides more business avenues, more revenue avenues for you. Before I get you out of here, quick update on the lubricant division. I get a couple questions in terms of what sort of products can this be used for, what's a market for it, when is revenue going to come in more from the lubricants division. Just give us a broad update here, please.
Yeah, sure. So the diesel engine testing is one of those things that is just got a lot of variables. And we've got an engine right now burning diesel, getting a baseline. And what we do there is we have different power settings, so different power generation outcomes. And then we weigh the diesel, as well as we do very highly calibrated flow measurement of the diesel as well. And what we're looking to do is a very clean, very accurate, and doubly measured and validated of the diesel per power. Then once we got that, and we know that we're on a good path, then we put the graphene additive into the engine oil, and then we do the whole same thing again. That's what we've been doing. We've been doing that for about the last year and a half. It is not simple. I've done this work in other parts, even when I was a fuels engineer for Shell, for big mining companies. It's difficult when you're even Shell. It's difficult if you're a big mining company. It's not simple, but it is worth it. We've been seeing customers saying they're getting 5 to 10% fuel reduction, and it's noticeable. They'll last another day, if over 20 days type thing with our product. And that's what we've got to prove to show a large company, say like Rio Tinto, who has an enormous amount of fuel that they want to reduce for many reasons. And they would love to save hundreds of millions of dollars of fuel burning and costs and of the emissions. And so that's why we need this data, because there's no way a large company will put their multi-billion-dollar assets at risk without having good data behind it. And so that's what we're focused on. It's a lot of tedious work, a lot of very detailed conforming and validation of fuel burning, and that's going to enable us eventually to be very clear what we've done. If you see the numbers for our coating and how accurate they are, and now we can estimate our coating heat transfer down to within a 1% accuracy of what our coating can do for air conditioners, well, that's what we want to do for the fuel as well. We want to be able to show within enormous accuracy detail that this is the level of fuel consumption we can do with G lubricant, and it just takes time, unfortunately.
Okay. Craig, thank you very much for taking time to break down these recent news releases. Again, you can also listen to the most recent interview that we conducted about a week ago, where we talked even more about thermal XR as well as answer a lot of your questions on the battery division. Again, Craig Nicol, founder and CEO of Graphene Manufacturing Group. Craig, thanks for your time. I'm sure we'll be chatting again soon.
Thanks, mate. Appreciate it. Talk soon.